We're going to do one more example for gram to gram stoichiometry. We're going to do example number 2. It's on this page right here, right? And I've got it blown up right here. So the example has the reaction N2 plus H2 makes NH3, where nitrogen and hydrogen yield ammonia, or nitrogen trihydride. The question says how many grams of NH3 ammonia would be produced if 25 grams of nitrogen reacts with excess hydrogen. We have to balance the chemical reaction. Here's a reaction with some blank spots to help us remember to put coefficients in. So I have nitrogen and hydrogen on the reactant side as well as on the product side. I have 2, I have 2, I have 1, I have 3. This one's pretty easy to balance. Right, oops, sorry. I have 2 to 1, so I'm going to drop a 2 in here. That makes that 2, and this is 6, because 2 times 3 is 6. So my nitrogens are good. Now I got to deal with my hydrogen. So I want 6 over here. I have to look here and figure out what coefficient to drop in to make that 6. And 3 it is. So here at step 1, I'm going to write N2 plus 3H2 yields 2NH3. There, I've just done step number 1. We'll come back to this when we need it. Right. Step number 2, identify the knowns and the unknowns. I do have this extra word and conversion factors. Take that out. I gotta edit this again. All right, the known. So it says how many grams of NH3 would be produced if 25 grams of nitrogen reacts with excess hydrogen. So there's 25 grams of nitrogen, 25.0, don't forget that, grams of N2, right? Because it's N2, it's diatomic. Don't forget, slow down sometimes. The unknown, what do they want? How many grams of ammonia, or NH3, question mark, grams, NH3. I'm going to take this one away. We don't need it anymore. Well, yeah. We'll need it for the molar ratio. All right, molar masses of the known. N2. I got N. I've got 2 of them. Each one has an atomic mass of 1401. So 2802 grams over 1 mole. Right. The molar ratio. Right, the molar ratio, here's the reaction. I have mole NH2 over mole NH3. So the N2 has a 1 and the NH3 has a 2. And my molar mass and my unknown. So NH3, I have N's and H's, I have 1, I have 3. 1401 is 1401. 008, 3.024. I add that together, I get 17,034 grams per 1 mole. Now again, this is something I've watched when students box off these conversion factors as well as make them nice pretty fractions. They do better. So we'll do that too. Boom. We have all our bits. Right? All right. Oh, I can't seem to use my fingers. Well, let's use this one. This will be better. All right. So I'm going to change the known into moles using the molar mass. So the known is 25.0 grams of N2 and that is always over 1. And I'm going to use the molar mass of the known, so here it is. My grams is here, 28.02 grams, so I gotta look here. Oh, grams is on top. So I'm going to put the 28.02 grams on bottom so that my grams cancel and my moles will be on top. I'm going to cancel these things out so that I know what unit I'm in. So I'm clearly in moles. Alright, next I am going to need this molar ratio. Alright, so I have 1 mole on top of N2. So that means I need to put the moles of N2 on bottom so that I cancel them out, and the 2 moles of NH3 on top. Again, I'm going to cancel out my like terms. Now I'm in moles of NH3, and I'm going to change the unknown moles. See, I'm in unknown moles, into grams using its molar mass. The mole here is on the top, so I'm going to put 1 mole NH3 on the bottom. I got that from right here, and 17.034 grams NH3 on top. Cross those out. I've used all the things I need. Now I'm going to pick up my calculator and do 25. 25 times 1 is itself, so divided by 28.02, enter, times 2, enter, times 17.034, enter. I have 3 significant figures here, so I can have 3 significant figures in the answer. My units are grams, NH3, and I'm done. Alright, friendly reminder, the process does not change. You're always doing the exact same thing, right? Alright, we're always starting in grams of the known, so you're always going to need the molar mass to get to moles. Then you need that molar ratio, balanced chemical equation, and then you need to use the molar mass of the unknown.